Oh yeah! In this video, we're gonna go over how to find the area between two curves, and it's gonna be pretty sweet. We're gonna start out with a basic one, and if you are a little questionable on what the concept is, you're gonna wanna check out my earlier video in this lesson so that you're in good shape on the concept. We're just gonna jump right into this. Remember, as always, keep geometry simple. Keep that as the leader of what we're doing. And let me show you what I mean. So we're given that we want to find the area of the region bounded by this. So again, we're going to sketch out y equals root x. So a rough sketch like that. That's y equals root x right there. Y equals -2 is a horizontal line down here. X equals 0 is a really fancy way of saying, hey, the y-axis. And then x equals 9 is this vertical line right here. So the region that's enclosed by those things is root x, x equals 0, y equals -2, and x equals 9. So what I always do is when I say keep geometry at the front of your brain, right? Let geometry lead, I'll say too. I mean drawing a rectangle, right? A really simple rectangle there. We want the area of that rectangle. So to find the area of that, we need the height and the width. The width is dx. The height, well, that is going to be this distance here, and that's going to be that value minus this value. No matter where you put the rectangle, it's always going to be the top curve minus the bottom curve to keep things positive. So what's the top value going to be? That's determined by root x. And the bottom value is consistently y equals -2. So I take this y value minus that one, and we'll get the height is going to be root x minus a -2. Or root x plus 2 is what it simplifies to be. Then we're going to multiply that by dx. So the area of your rectangle is going to be equal to root x plus 2 times dx. Okay, so that's the area of one tiny rectangle. We want infinitely many of them added up. So we're going to integrate that area. That'd be root x, and again, I like to lead with the geometry here, plus 2 times dx, added up infinitely many times. Now you're going to slide it from left to right, from x equals 0 to x equals 9. Imagine many rectangles stacking up until you sweep out that area. So that's going to be from 0 to 9. And I'm going to remind you that this is where you should stop. Go on to the next problem and practice the next one. Now, I'm going to continue and integrate it, but you should now go on, practice the next problem, set up, integrate it only at the end once you've set up and, well, come up and checked your integration, technique after the fact. Always set up the integral and then move on to the next problem. Bottom line, that'll get you more practice. Okay, so you got root x plus 2, and what do we do with that? We integrate it. So the integral of root x is going to be 2/3 x to the 3/2, and if you're like, how did he get that integral? Go back to my integration videos to check that out. Plus 2x, integrated from 0 to 9. This is all old school now. We use the fundamental theorem, plug in 9. That's going to be 2/3 times 9 to the 3/2, plus 2 times 9. Minus, when we plug in 0 into this and this, we get 0. But I'm not assuming that, I'm checking it. And now I simplify my answer here. You'll get 18 from 2 times 9. 9 to the 3/2 is going to be 27, right? The square root of 9 is 3, cubed is 27, times 2 is 54. Oh, okay. So that's going to be 54/3. Well, what is 54/3, you ask? Well, 54/3 is a really nice value. It's actually 18. Plus 18 is equal to 36. And there's your answer of 36. All right, on to the next one. Here we go. So y equals the square root of x, and y equals x squared. All right, so what do? We graph it out, right? No big deal. So you get y equals root x, like so. You get y equals x squared, like so. And what's the region bounded between those two things? Well, it's right here, right? It's all in there. Draw on a rectangle, throw in a little representative rectangle action. There it is. And now that we've done that, sometimes it's helpful for me to take a big look at that rectangle. Dx is the width. The height is this curve minus that curve. It never changes. That's always the top curve. So the top curve here is root x. That's this one. And the bottom curve is x squared. So the overall height is this minus that. So the height is root x minus x squared. That's times dx. That gives me the area of that rectangle. Now I want to integrate it from what to what? Well, we actually have to set these two functions equal to each other to figure out where they intersect. Otherwise, we don't know what the bounds are. So we show that. I'll do that math here. X squared equals root x. I'm going to square both sides. I get x to the 4th equals x. I'm going to subtract over the x. Never divide both sides by an x, that gets rid of a 0. And you're left with x times x cubed minus 1. Ah, what are my two answers? Well, I'm going to get x equals 0 from this. So that's my lower bound. Nice, that's this point right here. And then I'm going to set x cubed minus 1 equal to 0. Well, the answer to that's going to be 1. We see that when we have x cubed equals 1, cube root x equal to 1. So what that means is I've got an x value of 1 comma, and if you plug in 1 into this, 1 squared is 1, and an x value of 0 and then 0. So you're integrating from left to right from 0 to 1. That's it. That's your setup. That's the new part. Now all we have to do is integrate, but this is the new part here. All right, the rest of this is old school. We integrate root x. We just did that. It's 2/3 x to the 3 halves minus x cubed over 3. And these numbers are very nice. From 0 to 1, we plug in 1. You'll get 2/3, because 1 to the 3 halves is 1, minus 1/3, 1 cubed is 1. Minus, when you evaluate 0 into each of these, they will 0 out. And this simplifies down to 1/3. So that is the area, the exact area of that region. That's it. Keep that geometry first, and you'll be winning every time. I'll see you in the next video. Peace.